Right, we carry on with the mathematics, the terminology of and operations with common fractions. So they also say about 12 hours. The learning outcomes, you can go through. I'm not going to read through everything now. But go through your outcomes so that you know what you are doing and why you are doing that. The common fractions on the number line. Let's go through this, number 3.1. The common fractions as points on the number line from 0 up to 4, and then they have up to 10. So all those whole numbers that you see there. And as we know, 7 greater than 7 means 7 is larger than 5. 7 is more than 5. On the number line system, we also have then fractions. We can also have negative numbers. For example, if we owe somebody money, we have negative numbers of money. And then 0 and 1, between 0 and 1, 1/10, 2/10, 6/10, 9/10, and so we can carry on. We can also place common fractions on the number line. 1/4 and 2/4, which is also half in the middle between 0 and 1. 3/4, 4/4 is the same as 1 whole. On the number line, we can also see easily which fraction is larger than another one. So 2/5 is more than 1/5. And then we can also again see that 1 whole is the same as 5/5. Example 3. There we have the 0 up to 1 with the 10/10, 1/10, 5/10, 8/10, and so on. The fractions. How do we add and subtract common fractions, including mixed numbers? The basic competency, we must be able to add and subtract them, and the mixed numbers as well. This fraction chart we see in the grade 5 book. 1 whole divided into 2, then you have half, and then 1/3. And 1/12 is a very small part of 1 whole. But then we can also see which numbers are equivalent to each other if we use a ruler, and then we can see which numbers are the same, which fractions. Like on this line, we can see that 1/3 is the same as 2/5. No, can't be. Yes, I'm lying. 1/3 is the same as 2/6. And 1, 2, 3, 4 12s. So 4 12s is the same as 2 out of 6 is the same as 1/3. But use a ruler, otherwise it might look confusing. Example 1, we can calculate 3/5 plus 1/5. But the denominators must be the same. Luckily in this case, the denominators are the same, 5 and 5. So we can easily say 3 plus 1, which is 4/5. The same with 3/4 subtract 1/4. The denominators are the same, so we can just say 3 minus 1, which is 2/4, simplify to 1/2. Now we must calculate, in this case, 2 and 3/4 plus 1/2. We can add the whole numbers. 3 plus 1 is 2 plus 1, which is 3. And then we must add 3/4 and 1/2. But we must have the same denominators. So 1/2 is the same as 2/4. Then we say 3/4 plus 2/4, 5/4. We can see that there is 1 whole and 1/4 left. So 3 plus 1, 4 whole numbers plus a 1/4. And when we subtract, we can say that 2 minus 1 is 1, and then we have 1/4 minus 1/5. But we must make the denominators the same. An easy way is to say 4 times 5, which is 20. 4 divides into 25 times, and 5 divides into 24 times. So 5 minus 4, which is 1/20. The answer, 1 plus 1/20. Right. There are some more examples of those, subtraction and addition. Now if we have mixed numbers, mixed fractions, there we see we have 1 and 1/5. This 1/5 is the same as 2/10. 3/5 is 6/10, and so on. Right, we can carry on like that. I think there's a half. On this number line, you can see 10 fractions. Calculate each of the following sums, 2 and 3/8. So we can see it is 5/8. And if you work from the mixed fractions number line, you can add those numbers up. Extending multiplication of whole numbers. Work through these examples. 4 times 9 means we have 4 lots of 9, and that is 36. So the same we can say 4 times 2 out of 9. It means 4 of 2 9s. So 4 times 2, which is 8 9s. We can write it as 4 over 1 times 2 over 9. And then we say 4 times 2 is 8, and 1 times 9 is 9. If we simplify fractions, half of 6/8, we can divide. 2 divides into 2 once, and 2 divides into 6 3 times. And then we say 1 times 3, which is 3, and 1 times 8, which is 8. So we can always simplify before we multiply. The same here. If you have 3/4 times 4/5, we can divide. 4 divides into 4 once, and 4 divides into 4 once. And then 3 times 1, and 1 times 5. So 3 over 5. The same there with the rest of them. If we have to divide with fractions, what is 3 divided by 1/4? This is the same as asking how many quarters are there in 3. There are 4 quarters in 1 whole. This means that 1 divided by 4, or 1/4, is 4. And there are 12 quarters in 3 wholes, so 3 divided by 1/4, that is 12. To make it easy, we can say 3 times 4, and that is 12. But to make it easy to work it out, we can say 3/5 divided by 3 over 5. It is well known that a number divided by itself gives us 1. Therefore, 3/5 divided by 3/5 is 1 again. But we know that we can say 3 divided by 5 multiplied by the reciprocal of the next number. So 5 divided by 3. 3 divided by 5 and 5 divided by 3. 3 divides into 3 once and once. 5 divides in once. So the answer is 1. So we multiply with a reciprocal. We switch the 3 and the 5. The same with this one. If we use general knowledge, we say 6 divided by 8 multiplied with 5 divided by 3. So we multiply and find the reciprocal of 3 over 5. So we just swap the 5 and the 3. 3 divides into itself 1 time and into 6 2 times. 2 divides into itself once and 2 divides into 8 4 times. So 1 times 5, which is 5, and 4 times 1, which is 4. 5 divided by 4. If we simplify, we have 1 whole and 1 quarter. Sorry. Okay, there are some more examples of what we can do. If we look at this one, how to express one quantity as a fraction of another quantity. The example, in your class you have 30 learners. 20 of these learners are boys and the rest are girls. What fraction of the class is boys? And B, what are the girls? So the number of the boys are 20 out of the 30. So simplify 20 out of 30. We can cancel the zeros, so it's 2/3. Then we know there are 3/3 in a whole. 3/3 minus 2/3 will give us 1/3. Sorry. So we can formulate a rule. Let's see what the rule is. To express one number as a fraction of another number, write the first number over the second number to make a fraction. And then simply simplify. The same here with centimeters and meters and money. We can do the same. Here are some learning activities as well. To construct paper models. If you have a blue piece of paper and a red piece of paper, you make it in half. Just fold it in the middle. And thirds and quarters, you fold it in the middle and in the middle again. Then the learners can easily see that 1 whole is the same as 2 halves and 3/3 and 4 quarters. Because sometimes fractions are very difficult for the learners to know that you have to divide into different groups. Okay, the next part that is very important is the perimeter. We must know the formula. The perimeter of a square with sides L is 4 times L. Perimeter around the figure. The perimeter of a rectangle and the width, so it's 2 times the length times plus 2 times the width. And the perimeter of a circle with a radius r, 2 times pi times the radius. Then area, something else. The area of a square with the sides L is length times length, so length square. The area of a rectangle is length times width, and the area of a circle, pi times radius times radius. It is very important to show the learners between the perimeter and the area of all these figures. And how we find the volume of a cuboid. For example, use a shoebox to show the learners. It is length times width times the height. And the volume of a cube, some square that you have, or a cube, like a dice. So it is length times length times length. Very important to show learners in the junior school the difference between the perimeter, the area, and the volume, and how to find the different ones. Right, that was Unit 3. Now I'm carrying on with Unit 4, which is the terminology and operations with decimal fractions. Decimals can be very difficult for learners, but if we teach it from the beginning the correct way, then it's not so difficult. If you look at this example, what is the number 5,3078? The 3 is the 10th position. The 0 is in the hundredths position, and the 7 is the thousandths, and the 8 is the 10,000ths. And the 5 is the whole number, the unit. And to make it practical, we can use a 10 by 10 centimeter grid, and we can fold the paper or draw the lines to see what is one of these small blocks and what is one whole block of that. And on the number line, between 0 and 1, we have 1/10, which is the same as 0,1. 2/10, the same as 0,2. And 6/10 is the same as 0,6. To show the learners on the number line the decimals as well as the common fractions, that it is the same and where it is the same. But make it practical for the learners to have your grid and to fold it or cut it even in pieces. If we have common fractions, we can see that a half is the same as 0,5 and a quarter is the same as 0,25. 1/5, 0,2, 1/8, 0,125, and 1/10 is the same as 0,1. And then sometimes we get recurring decimals and how we write it then. For example, 8/15, if you work it out on your calculator, you get 0,53333, so it's recurring. Then we write it 0,53 with a dot on top of the 3. So that means the 3 is repeating. The same with 2/3. You get 0,6666 and we write it as 0,6 with a dot over the 6. And there's then an example how we round off. For example, 0,714 to the nearest whole number. The digit to the right of the whole number place is 7. This is more than 5, so the 0 becomes a 1. So 0,714, it is 1 correct to the nearest whole number. Sometimes that is very difficult for the learners to understand. Let's look at example 5. 0,0736. If we must write it correct to one decimal place, the 7 changes the 0 to 1. So it is 0,1. And then correct to 2 decimal places, so we must look at the 7 again. 0,07. The 3 does not change the 7. So it stays 0,07. 0,07. Correct to 3 decimal places. We must look at the 3 and the 6 here. So we write 0,07. The 6 changes the 3 to a 4. 0,074. Correct to 3 decimal places. There are some exercises again. The addition of fractions. Remember to write the commas underneath each other and put zeros for placeholders, and then you simply add up from the right to the left. Subtraction, 12,48 minus 7,53, the commas underneath each other, and start from the right and subtract. 8 minus 3 and 4 minus 5, we have to borrow. So then we have 14 minus 5, which is 9. And then 11 minus 7, which is 4. Multiplication. We all know how to do that. How we multiply. We write the numbers underneath each other and start from the right again when we multiply. Division. And here are some answers even in your unit. If we look at this table here, we see this is a 5,300,000, 40,000, 6,720 and 9. And there are, after the comma, 0 tens and 0 hundreds and 0 thousands. Right, and then there are some emotional support to the learners that we can read through. And teachers must be sensitive. And here are some nice examples that you can also work through, and the summary. So that was Unit 4. Then we carry on with Unit 5. Conversions and word problems involving percentages. So here we start with the percentages. There are the learning outcomes again. Common fractions and decimal fractions we've done, and now we start with the decimals. And the link between the three of them. Right, let's go through one of these examples. Example 3, write half as a percentage. So half, we must multiply with 100 over 100. And before we multiply, we try to simplify by cancelling or dividing. 2 divides into itself once, and 2 divides into 150 times. And then we multiply. 1 times 50, which is 50, and 1 times 100, so 50 out of 100. 50%. So a half is 50%. Example number 4. Write a quarter as a percentage. A quarter we multiply with 100 over 100, and if we simplify, we get 25%. 2/5 as a percentage. 2/5 times 100 over 100, so it's 40%. Let's go through these examples. Example 1, write each of the following percentages as a fraction. What is 5%? So 5% is 5 times 1 over 100. So it is 5 over 100. And if we simplify, 5 divides into itself once and into 100 20 times. So 5% is 1/20. Number 2, change the percentage symbol into 1 over 100. So we have 250%. 250%. 250 times 1 over 100. Simplify by dividing, and then we get 5 over 2, and 5 over 2 is 2.5. So 250% is the same as 2.5. 7.5%, 7.5 times 100. The 7.5, the mixed number, we must make a number with 15 over 2. So 15 divided by 2 times 100. Simplify by saying 5 divides into 15 3 times, and 5 divides into 100 20 times. And then 3 times 1, 3 and 2 times 20, which is 40. 7.5% is the same as 3 out of 40. So we can carry on doing that. So that is a percentage as a fraction. And then we always simplify. If we look at this example, 0.4 as a percentage, 0.4 is 4 out of 10. We know that. 4 tenths times 10 over 10. So it is 10 times 10, which is 100, and 4 times 10 is 40. 0.4 is 40%. And the same here, 0.25 is 25 out of 100. So we make the decimal a common fraction. And because the denominator is already 100, we don't have to do a lot of other workings. So 0.25 is 25%. Here we see some real life examples. The following are examples of real life percentage problems with compatible numbers. Simple drawings help with the reasoning. How much does a coat cost on sale? It is 20% off the coats. So what is 20%? It is 1/5. So $90 it was. We must cut into 5 parts. And each part is now 18. We can say 90 divided by 5 is 18. 18 times 5 is 90. So that leaves us with 4 out of 5. So what is 4 times 18? 72. The sale price of the coat is now $72. Number 2. This year 20 more learners came to school by bus than last year. If this is a 10% increase, how many learners used the bus last year? The reasoning, 10% is a tenth, so 10 times 20, 200 learners. So last year there were 200 learners that came with a bus. This year there are 220 learners on the buses. So it helps to make it in a drawing where you divide it into the percentages. Number 3, the Roads Authority is responsible for 600 kilometers of 2-lane roads and 300 kilometers of 4-lane roads. What percentage of the roads is 2-lane? The roads, 600 miles is 2 lines, and okay, in our terms we will say kilometers, and 300 kilometers is 4 lanes. Draw it and reason it. The 600 kilometers are 2 lanes, so there are 2 parts. The 300 kilometers are 1, 2, 3, 4 lanes. In total, the 600 plus 300 will give us 900 kilometers altogether. And 6 is 2/3 of 9. 6 is 2/3 of 9. So 600 kilometers is 2/3 of 900 kilometers, which is 66,6666 or 66 2/3%. And now, the role of estimation in solving problems that involve the percentages. Let's look at the first problem here. Estimation is very important to give the learners an idea of what they can expect as the answer. The problem is 83%, the 83,000 seat rugby stadium was 73% full. How many people attended the rugby? So, use 3/4 and 80,000. That's about 60,000. So if we have to estimate, but we can work it out, 73%, 73 out of 100 times, it was 83,000 people, and divide it. We can cancel the zeros, and then with your calculator you can work out 73 times 830, which will give you how many people were there at the rugby. Okay, there are some more problems. Here's an example of how to express one quantity as a percentage of another quantity. Write 20 as a percentage of 80. So we write it as a fraction, 20 over 80 times 100 over 100. And simplify 20 out of 80 over 100 over 100. And that is 20 over 100. Instead of writing 25 over 100, we say 25%. We see the percentage sign is taken from the 100. We have the 100, that is the same as, there's our 1, there's our 0, 0. So 100 is the same as a percentage. There's the 1, there's the 0, and the 0%. Example number 4. In a basket of fruit, you have 16 apples. You can draw the apples for the learners, and 4 oranges. You can draw that, and even color it orange color. What percentage of the fruit is oranges? So we use the 4 divided over what? The total of the fruit. So 4 plus 16. Not 4 over 16, but 4 plus 16. The oranges plus the apples. So 4 divided by 20 to find the percentage of oranges. 4 divides in once and 4 divides in 5 times. So it's 1 over 5. 1 over 5. But that is not, that's a fraction. That is not the percentage. So we still have to multiply 1/5 with 100 over 100. And so it is, we can divide, 5 divides in once and 5 divides into 120 times. So 20 over 100, which is 20%. 20 over 100 is 20%. So the oranges were 20% of the fruit. Here we come to percentage profit or loss. The percentage profit is the actual profit and over the cost price times 100. The percentage loss is the actual loss over the cost price times 100%. And let's look at one example here. A shopkeeper buys an article for 500 Namibian dollars and sells it for 600 Namibian dollars. What is his profit? So the cost price was 500. The selling price is 600. The profit is the 600 minus the 500. So his profit is 100. So the 100% over 5, that is 20% profit that he made. Let's look at this example 2. A woman buys a car for 160,000 and then she sells it for only 120,000. What is her loss? The cost price is 160. The selling price is 120. The cost minus the selling is 160 minus 120. So her loss was 40,000. 40,000 over the cost price, 160,000, times 100%. So that is, we must divide, and then we get 25%. Right. So we can cancel the zeros. There are 4 zeros to cancel. 4 divides into 1s, and 4 divides into 4 times, into 16. So 100% divided by 4. 100 divided by 4, 25%. Okay, there are some more examples of those, and then word problems. There are some classroom activities, what they can do, what is a profit, what is important to make a profit and not only loss, and how we calculate it. Because most of the learners will one day become entrepreneurs, selling and buying, and how they must be able to make a profit and not only to make a loss. The next unit is on measurement of length and mass, capacity and time, which is also very important for real life, to teach the learners how to measure the length, millimeters, centimeters, meters, kilometers, what mass is, what is the capacity of, for example, a glass or a dam or a diesel tank, and how to read time and how to spend time to find the value of how you've spent your time the whole day. The symbols, we know the M is for the meters of length, kilograms for mass, and S for seconds of time. And in real life, to measure the length of the guitar, it is about 1 meter. And this gold bar has a mass of 1 kilogram. This dictionary has a mass of 1 kilogram, more or less. 1 second is about as long as it takes to say 1001. 1001 takes 1 second to say that. And then a square, 1 meter by 1 meter. That's about the length of a desk in the classroom. What is the area? You must know how to find the area and how to find the capacity. The capacity, the volume of this cubic meter cube. This is a cube, 1 meter by 1 meter by 1 meter. The length, the breadth and the height, or the length, the width and the height. To find the volume, 1 times 1 times 1, which is 1 cubic meter. And 1 cubic meter is 1,000 liters. 1,000 liters is the same as 1 kiloliter. And that is 1 cubic meter. Liter is abbreviated to L. So 1 cubic meter is 1 kiloliter. It is 1,000 liters. Very important that learners should know that. And where it comes from, all these different things for small numbers. And then the converting units of length, the millimeter, symbol mm, 10 millimeters is 1 centimeter. And centimeter, 100 centimeters is the same as 1 meter. And 1 meter, m. These things the learners must know. The milligram, the gram, and the kilogram. 1,000 milligram is the same as 1 kilogram. Capacity, milliliters, 1,000 milliliters is the same as 1 liter. Conversions. Convert 55.4 kilograms to grams. We must multiply with 1,000 because there are 1,000 grams in a kilogram. So 55.4 we multiply with 1,000. 55.4 times 1,000 gives us 55,400 grams. Example number 2. We must make these grams into kilograms, so we must divide by 1,000. If the comma is now there, we divide by 1,000. We can say we move the comma 3 places because 1,000 has 3 zeros. 3 places back. 1, 2, 3. So the answer will be 0,25. Or 0,25075. We use that number and we put a 0 in the front, comma, 1, 2, 3 places, the comma was there, kilograms. We divide by 1,000 and we must make sure we write down the unit, kilograms. Example number 3, this is grade 5 work. 4,75 kilograms, we must make in liters, or kiloliters, we must make liters. We multiply with 1,000, because there are 1,000 liters in a kiloliter. So multiply with 1,000. The comma was there right after the 4, so we move it 1, 2, 3 places. Now it is 4,750 liters, the same as 4,75 kiloliters. Right, in there are activities. We must always be able to add numbers the correct way and to subtract numbers. Make sure your units are the same. Meters right through, liters right through. It must be the same. The same here, it can't be grams and kilograms mixed. So first of all, we must make these grams to kilograms. So we must divide by 1,000 to make it into kilograms. You already know that we can only add or subtract quantities of the same kind. Therefore, 2,5 grams, we must make it to kilograms. First of all, we divide by 1,000. So if the comma was after the 2, it moves 1, 2, 3 places back when we divide by 1,000. And now we have everything in kilograms. Your answer must always have the unit, meters or liters or kilograms as well, and not only the number. And then to multiply with one number, that is quite easy. 4,7 meters multiplied by 3. So we can say 4,7 multiplied by 3. We start from the back. 7 times 3 is 21. 4 times 3 is 12 plus 2, 14. And remember your comma. The question was in meters, so write your meters down. And your lines you always draw with a ruler, not like me, only with your hand. If we divide, we must remember to teach the learners, division starts from the left. Multiplication starts from the right. So how do we divide 8,4 by 2? We can say 2 divided into 8, that is 4. And 2 divided into 4, that is 2. Or, normally they do it like this, 8,4 divide 2. 2 divides into 8 4 times, put your comma. 2 divides into 4 twice, 4,2. Right. And that was in liters, so remember your unit there as well. There are some examples that learners can do, but once you see they've mastered the competency, you carry on with the next part, because mathematics has quite a lot of things that learners have to know, not only plus and minus and divide and subtract. They need to know a lot of other things. Very important to teach your learners that 1 century is 100 years. They don't know it. They don't know that a year is 12 months. from January up to December. They don't know that 1 month is more or less 4 weeks. And 1 week has 7 days, Monday up to Sunday. They don't know it. And they don't know that a day has 24 hours. You must teach them that 1 hour is 60 minutes and 1 minute has 60 seconds. So they must be able to do this and to read these schedules. This is a schedule of the arrival and departure times of international flights at the Hosea Kutaku Airport outside Windhoek. There are the flight numbers, the arrival time, and the departure time, and where the people are going, to Cape Town or Joburg or Victoria Falls or Cape Town again. What time they arrive and what time they depart. Then they must be able to subtract and add time. And they must also remember that there are 60 minutes in an hour and 60 seconds in 1 minute, and not 100. So number A, how long does flight this stay on Hosea Kutaku Airport? The time that the flight stays is the difference between the arrival time and the departure time. So departure minus arrival. So we must subtract. And this one is exact, 0.0845 minus 645. So it is for 2 hours on the airport. Number B, to which destination does flight ZA1056 fly from Hosea Kutaku? So they must be able to read the schedule here, 01056. Where do they go? They go to Cape Town, destination. You see how important the English is. To teach the learner what it means if we talk about the destination and arrival time and departure time. And that there are flight numbers. Number C, if you miss the first flight in the morning to Cape Town, how long do you have to wait for the next flight to Cape Town to arrive? So you have to look at the arrival times of these flights. So 15:20 minus 8:45. 15:20 minus 8:45. 15:20 Cape Town and departure time 8:45. So we must work this out, what that is. So you will have to wait from 8:45 to 12 o'clock and then from 12 o'clock again to 15:20. So you will have to wait 6 hours and 35 minutes. You can work it out hour by hour and then minute by minute. There's another example, the same type. And this looks like the example that we have in the grade 5 book. The following is a timetable for grade 7s or grade 7s in this case. Bible and English, and so they carry on till Afrikaans at 0:30 a.m. It can't be 0:30, but anyway. At what time does the school start? It starts at 7:15, but they say write the time out in words. How long is the interval? How long do they have break? They have the interval here. How long is that interval from this time to that time? So 9:55 minus 9:15. How long is each lesson period? Example, you can take 11:50 and 11:10. What is it from 11:10 up to 11:50? How long is that period? How long is a school day for the lessons? How long do they go to school? And at what time does the interval start? What time do they begin break? 9:55, they start their break. And when does the second lesson for English start? There are 2 English lessons. There is the first one and the second lesson for English. So 11:50, they start with the English. Write the time 9:55 a.m. in the digital system. Okay, so you must write it in digits. How will it be written? 09:55. Not only 9:55. And there are some more calendars that they can study. Very interesting. The learners like to do this because it's practical. It's real life. And multiplication with time. Always remember 60 minutes in an hour and not 100. And subtraction with time. Again, the learners must remember about that. 60 minutes in an hour. Here we see some clocks. Some learners do not have clocks, so they don't know how to read the clock or a watch. Which 12-hour clock time matches the given 24-hour clock time? So what is the time on this watch? It seems like 5 minutes past 9. But we don't know whether it's in the morning or in the afternoon or in the night. Which one is the same? Or how do we write it in the 12-hour clock? So this is 09:05. But it could be also in the evening. So it is 21:05 in the evening. So 9 plus 12, 21. 9 plus 12 is 21. So which one is the same as 14 hours? In other words, 2 o'clock in the afternoon. This one is not like that, so it will be number B. 2 o'clock. Teach the learners the long hand is for the minutes and the short hand is for the hours. Because they don't know this. Unless they have a watch and they can look it on their own watch. So here we see a dog on the balance, how we can measure the mass of people and all those different things. Very interesting for the learners to know what their mass is because they don't know. They will say they are having a mass of 200 kilograms and not knowing that then they are very, very fat or something. Right. I see here how you can organize and store your mathematics materials. In a shoebox, place your equipment needed for a specific concept in one box and mark it clearly. Have a list of the materials contained in the box on the outside of the box so that the learners know what they are using for which activities.